Hello, Professor. I am Saiteja Kondapalli from class CS 513, and today my topic is about scheduling partially ordered events in a randomized framework, empirical results, and implications for automatic configuration management. In this article, the authors have mainly described about how managing the resources and security and randomization technique and scheduling of events and configuration management, improving efficiency of the system, malicious intervention and controlling the malicious surveillance, and the results of all these experiments and providing the optimal topology for scheduling the events in a system. And this presentation is mainly about how important in scheduling events using a randomized technique, and also how it uses the configuration management tools in this process to execute these events. And in a distribution configuration management system, the resources are shared in between the machines and every task needs a resource to complete its process. This experiment is mainly focused on three factors, which are efficiency, robustness, and security. When an event is using less amount of resources, then it is called as an efficient process, and when the process is having less errors, then it is considered as robust. And the security is mainly based on the how importantly hiding the management model from the observers. In this random behavior of scheduling events, make sure that it is difficult to predict the management model, by which it reduces the accuracy of predicting the future behavior. This random scheduling has more advantage than traditional scheduling method, as it is efficient in using its resources, and also it the authors have mentioned about several tools like CF engine, which is based on the configuration of automatic management model, and it also has access to create, modify, and delete the files during the process. And there are three sets of experiments conducted in this research. And first set of experiment deals with the efficiency of how efficient this random scheduling in maintaining this configuration management. Here, event is generally known generally mentioned as a file which triggers this management tool for the execution, and there are events which are mentioned in an order in a graph, and the execution process takes in the same order which they are scheduled. And the first experiment is mainly focused on finding the optimal schedules which uses in the specialized scheduling algorithms. And this management model mainly deals with the security and the availability how of the resources and how efficient the events are using these resources. And the second experiment is based on which randomization technique is useful for maintaining of security and maintaining this configuration model. And in this technique, the observers are trying to predict the configuration model, and the main aim of this experiment is for the system administrator to design a configuration model that is different from the previous one. When the system administrator controls the security, he should always reorder the configuration management so that the observer cannot be able to uh, predict the design of this configuration model. And the third set of experiments is on finding how observer able to monitor the configuration model. And when we use the randomization model, the observer cannot be able to reconstruct the configuration. And even though by continuously observing the system, he cannot be able to get the desired outcome he wished. And management of resources, there are two types of scheduling methods mentioned in this article, which are dynamic scheduling and static scheduling. And in this in this dynamic scheduling there in this scheduling method, there are also several jobs like production scheduling and multiprocessor scheduling, which have also mentioned by the authors. Dynamic scheduling is mainly used in dealing with the time variant problems. The resources here are allocated for a certain time to complete the process, and nowadays many modern operating systems follow this method of using dynamic scheduling. This process is continuously stopped and started by the users within the system. And the static scheduling is known as fixed scheduling, where it assigns resources to a fixed problem which is certain, and these resources are cannot be shared by another task. In these resources, they are set to complete a single task, and the process completes with much faster and using less amount of resources than the resources uh, shared by the other systems in the dynamic scheduling. Security and randomization. In the scheduling process, all the errors can be resolved by using this topological sorting technique, and it uses a technique called free list where the nodes are filled with the tasks that have no parent. It's like the problems in the scheduling can be solved when the tasks are ordered in a particular order, like using the topological sorting technique. Here in the graphs, the tasks are represented with the vertices, and these vertices are added to the graphs by the method called freelist, where the independent nodes are added at the starting of the process, uh, in in the place which they have desired. The scheduling of tasks is based on their level in the graph, and these tasks with the large number of successors have always priority over the tasks with the less number of successors. Here we select these tasks using a random technique, and this technique makes the observers to predict the process, and which also improves the security of the process. And it is really hard to execute the repetitive attacks when we are using this randomized technique, and when selecting the tasks, which makes the process also secure and efficient. And this randomness does not even repeat the same process which we have used in the previous methods. Scheduling events and configuration management. In distributed management systems, the scheduling of events is difficult due to many interrelated precedence relations. Like these relations are in between the systems, and these are represented using a graph. These dependencies are mainly two types, which are intercycle dependencies and intracycle dependencies. Intercycle dependencies mainly occur within the system cycle, and these intracycle dependencies are occur across the cycles but in the same network. The configuration management models are mostly cyclic dependencies, and in these configuration models, uh, this research this research which the configuration model in this research the configuration model uh, mainly uses both dynamic scheduling and static scheduling techniques. When this configuration model state is in the static scheduling, then the users cannot be able to change or modify the files in the system, and when it is in the dynamic state, modify which they can be able to modify the configuration actions according to the task which is required. Improving efficiency of the system. Configuration management consists of several activities like monitoring the process and controlling managing the storage and file structures. It also modifies the storage by adding, deleting, copying, and moving files from one system to other system. The process of operating the scheduling is time consuming, and also it needs a lot of resources to complete the process. There are two methods which manages the execution of these files, which are local and remote execution. In the local management of operations, these are done within the system, and the files which are present inside the disk drivers of the systems can be used efficiently for execution purpose. And in the remote management method, we need to have an access to the files which are located remotely in between the systems. And These files are located across the systems and within the across the systems within the same network, same computer network the execution is processing. And many system nowadays uses these kind of techniques, and there is a direct memory access controllers which are used by many computers, and these controllers are used to transfer the files in between the system's memory and also the peripheral devices which are present in the network like network cards, etc. In this process, it does not require the processor to manage the execution process as it is in as it follows the asynchronous type of execution. In this asynchronous type of execution, the process of execution does not require any help from the processor, which makes the processor can use which makes the processor can execute or concentrate on the other tasks which are currently going in the system. And this type of execution is also known as parallel execution, which helps the tasks in the system, which helps the events in the system execute much faster. And there is the other type of technique called synchronous type of execution, and in this synchronous type of execution it should have to take the help from the processor to complete the process, and it cannot be able to execute the task parallelly in the system or in the background where it makes the processor busy until it finishes the process of the previous task. And by using this asynchronous type of technique, it is very efficient and very less time consuming, so it will be helpful for the processor make sure to execute more events in a less amount of time. And the remote operations are mainly using a technique called remote procedure call, and this remote procedure call is used to initiate the response between the systems, and it is also helps in sending and receiving the messages or the data that requires by the processor in between the systems within a network. Malicious intervention. The experiments which are done on this malicious intervention are based on how the observer monitoring the process and how it is affecting the security and integrity of the system. It assumes that observer knows about the structure of the configuration model which currently implementing in the execution process, and also he can be able to monitor the transactions which which will be helpful for him to know the design and implementation of the current configuration model that has been deployed in the systems. And he also tries to modify the transactions when by updating the transactions with his own set of instructions, and this spoils the system administrator design and instructions of using of executing the events within the system. And it also spoils the reliability of data which that has been instructed to execute all these events. This observer can also be able to use this knowledge to store a large amounts of data which also degrades the performance of the system by making the system lagging during the execution process. And this data is stored in large amounts, and the data out of its capability of the storage capacity of the resources within the system, and these user finds temporary storage areas which is shared by the other users. It's like this data is stored at the temporary storage areas where the observer can have the access to the data of the other users, and that could spoil the security of the data which has been stored by the other users in the same system. And this mainly occurs in the distributed systems where the resources can be shared in between the systems. When the system administrator designs a model, the observer tries to tries to observe the model and test a multiple amount of times so that he can be able to have the access of the data which is present inside the system. So here the system administrator really needs to focus on designing the model that should be randomly selecting the events rather than following a fixed strategy which could be easily predicted by the observer. Here the observer can be able to manipulate the process, and when using the random technique that has been applied for the execution of this process, the scheduler which access the data randomly by using the code that has been implemented by the system administrator. And this kind of model this kind of model is difficult to predict the observer because it gives a new result or new execution process every time the events has been executed, every time a new event or task has been taken to the execution. And in this random process of scheduling, it is mainly based on a technique called freelist, and these freelists have several thousands of iterations for each task. And iterations out of these iterations, this technique picks randomly a single iteration, and this iteration will help in solving the event at that particular period of time. And this technique is difficult for the observer to predict, and when the graph is dense in this randomized technique, the scheduling of events is also high. And here the size of the configuration does not really affect the predictability of the observer, and mainly the good connectivity in between the systems in a network has leads to the more dependencies in between the system, which reduces the accuracy of the predictability process by the observer. Malicious surveillance. And in this experiment, it is explained about how observer able to monitor and how he able to manage the configuration model of the system. This this ma- this surveillance is mainly about the process of finding out how this observer able to predict the model. We assume that the user wants to store the data in the files in the system, but every day there is a cleanup process that is scheduled in between 2 a.m. to 6 a.m. in the morning. And when the observer sends the data every single hour to the system, he can be able to predict that the cleanup process is taking place at a certain amount of time. And this, by sending the data for a consecutive days, he will be able to manage the design of the predictability, manage the design of the configuration model, which he can be able to easily alter the model by using his own set of instructions. So when the system administrator follows the same pattern of execution by cleaning up the process at the same time period, then it is really then each time then the observer can be able to predict the pattern by conducting experiments for several days, and which reduces the security of the implementation process. And when the system administrator uses a random strategy in scheduling, then the execution process each time takes a new task, like every day it follows another period of time for the execution. And by the scheduling process, the task has been processed at a different time, and so that the observer cannot be able to predict the time when the event is really executing in this execution process. And this randomized scheduling of events, the design of the algorithm is based on several observations, and when any task that has been scheduled before or after the present task, then it is considered as an independent task or independent event. When an event is occurred or executed only before the present task, then it is called the parent of the present task. And when it is scheduled for the execution after the present execution of event, then it is considered as the child of that event. And when all the other tasks are independent to the present task, then they are called exit nodes. And when all the execution of the nodes that are before the present nodes are independent to each other, then they are called entry nodes, and these nodes, they have no parent nodes. And results of experiments and optimal topology. After conducting several experiments in this research, it is suggested that using this randomized scheduling makes the graphs denser, and it also obscures the topology of the structure, by which the structure of the management and configuration model. When the management structures have more number of nodes in the structure, then it has a strong connectivity in between the nodes, and it makes the system less predictable. And these layered structure graphs with good connectivity between the nodes are very hard to predict, and it is really considered as optimal topology or optimal configuration model, and it has more layers and good graph density compared to the normal topology of methods. Conclusion. And in this research, it is mainly deals about the randomized selection of events and with in a distributed environment. And it is mainly concentrated on three factors, that are efficiency of using resources and controlling the predictability by the observer, and also extent to which how observer are able to monitor and identify the configuration model. And this results of the graph describes that by using free list, it is difficult for the observer to predict the management model, and this randomized scheduling has advantages over the order strategies where when any time variant task that has been processing. And here it is even more difficult to predict the configuration process than using the order strategies for an event for the execution. And by using this random technique for scheduling, it is easier to understand and implement, and many modern systems right now uses this automated distribution of configuration management tools to implement this technique. Thank you.